Students, welcome to online classes and continuation of AC motors. In this session, we are going to study one important and interesting topic, that is double cage rotor induction motor. Before starting our class, my sincere thanks and courtesy to all authors for sharing their valuable material for the sake of students. So, what we have seen in previous classes, let us recall just for a few seconds. What we have seen in the last class, we have seen that starters of induction motors. Now, what are the objectives of today's session? On completion of this period, you would be able to know one, the necessity of double cage rotor, construction features of double cage rotor, working of double cage rotor motor with circuit diagram, torque slip characteristics of double cage rotor motor, advantages of double cage rotor motor, and finally the comparison between single cage and double cage rotor motors. Okay, so dear students, let us see that what is the necessity of the double cage rotor motor. Before that one, so we will see once again what is the basic construction of our induction motor. From that one, how we are going to evolve with the double cage rotor. Okay, so let us see. Now you know that this is our induction motor. It has a stator 3-phase winding and 120 degrees apart. In case of squirrel cage, the rotor windings are inserted in a slots and we connected brass at end rings, we soldered each other. Okay, it looks as a squirrel cage. In this case, what will happen? A copper parts inserted in a slots, short circuit is closed. Whatever the current flows and circuit is closed. And in case of rotor wound, so another rotor is made up of the slots and made with slip rings, and this winding is wound on this one similar to the stator winding, and this winding is given to the 3 slip rings, and from the brushes we are going taken out. This is the slip ring or wound rotor. Winding is wound on the iron core. Here is the squirrel cage. So what is happened here? What is the main difference? If you are inserted here as a rotor, then we can say this is a squirrel cage induction motor. If you are inserted here, then we can say the slip ring induction motor. Stator is same, but rotor is different. What is the difference between these two? So what is happened? This winding, if you inserted the squirrel cage, then what will happen? We are going to get the almost average torque will develop and it will run constant speed. Okay, so whereas in addition to this one, if you are inserted instead of this one, if you inserted this rotor, wound rotor, then we are going to get the starting torque. Starting torque is the more. Starting torque is more. So, where we require the more torque, we can choose for this type of the starters. Okay. So, this type of the starter generally used in this case. Okay. So, here suppose I want to, how the starting torque is increased, what is the difference? Because here the rotor conductors having the fixed one, whereas the rotor conductors owned here, we can add the some resistance externally with help of the one starter is connected here. By adding initially some resistance to the rotor winding, the rotor resistance increases. What is the formula? So, we know that the formula, so torque is directly proportional to what is the S into E2 whole square and R2 by R2 whole square plus Sx2 whole square. We have seen that formula also we derived. Then what is happened here? So, that means the torque which is starting torque, T starting torque at S is equal to 1 standstill condition, then so directly proportional to the R2. If rotor resistance is more, then automatically the torque which is initially is a more. So, that is a directly proportional. This can be possible in case of rotor circuit, because we are adding this initially as a starter as well as the some resistance added in the winding. Okay. So, what is this winding? So, it has some resistance and it has some initial coil winding. So, from this one we are going to adding some extra resistance in from externally. Then what will happen? So, this is the XL, this is the small r, this is the capital R. So, total resistance R plus R. Then, so here the R value increases. Okay. So, this value increases here. Hence, we are going to get the high starting torque. I require the same torque is required in case of squirrel cage also. How it is possible? But the rotor is fixed at the manufacture itself. The rotor conductors are inserted, braced at the ends. There is not possible to add any resistance in the circuit. Sir, at the time of manufacture itself, I can use some more resistance copper bars or brass bars inside. Then I can get the more starting torque. But what will happen? Whatever the resistance added continuously in the rotor circuit, that will evaporate more heat energy continuously whenever the motor is running under normal condition. If the heat is developed, losses takes place, then what will happen? The motor efficiency decreases. At the same time, I require the efficiency should be the more, starting torque should be required more. But in this case, if we added the more resistance copper bars in the rotor circuit, then continuously resistance presents. But our aim is to add, whenever I am weak, I can support my some stick or something. Initially, I require the only support. Once I pick up my energy, then no need of that one. Otherwise, what will happen? That may be loaded to me, that may be drawback to me. Hence, the resistance which is required at the starting itself only. Once I pick up, then no need of that one. Similar to our DC starters. In DC 3-point starter, what we have seen? So, to start the motor, so we have used the resistance stud by stud, stud 1, stud 2, stud 3, stud 4. We are slowly moving. So, once the motor pickups, once the back EMF induced in the rotor circuit, then afterwards we are going to total cut off the initial resistance. It is connected to the hold on coil. So, during this time I require the resistance. Once motor is runs at the normal speed, no need of the extra resistance in the circuit, otherwise that may be burden to myself. Okay, so it is not possible. But in case of the rotor won't resistor motor, it is possible. I require this also. What to do? Yes, there is a one chance. Okay, so that is known as a double cage rotor is possible in squirrel cage induction motor. Instead of single cage, I can use the two cages. That means, for example, you can take the one example. Suppose myself have, so myself, my wife, so I have the one son, so this son, what will happen is my varasudu, we can say the varasudu. Then what will happen? So both of always, so we will see this person. And suppose my brother has brother and his wife, and they have the one, so elder one is the girl and younger one is the boy. Okay, so girl and boy. I only having the boy only. What will happen here? If this person here, so here elder one is a girl, she can help to his mother at the time of starting time. So whereas his brother is a very younger, he cannot help, just he will follow his sister. Okay, so what will happen? She will help to his parents in all aspects. Here only this first fellow will always offer. Now let us assume, so this girl becomes the resistance, this boy requires the inductance XL. Now here I am going to get it only, so boy, that is the XL reactance purpose. Okay, now what is happen? Initially I require the some resistance is required, high starting torque. Up to before 21 years or 18 years, she will help, she will is the monitor his brother and family. She ready to help his parents perfectly. Then once she becomes 21 years, then she will goes to the marry, and she will go to the mother-in-law house. Up to marriage time, she will take care of his all house needs, and she will try to help his parents, always, due to his brother is younger one. Okay, so then once she gets marriage, she will go to his mother-in-law. Okay, then the person will take care of his house. During this period, he will becomes the grow, and he will take care of his parents. Okay, there is a two possibles, one girl, one boy. They are happy, they will help together to their parents. In this case, what will happen? Initially, the boy XL is having the limited from starting to at the end of the life of the parents, he will take care of single person only. Here, instead of this one, two girls, two kids, one kid will help initially, and afterwards he will take care of this one. Otherwise, if suppose she is not married, then what will happen? She is a burden, she may be burden to his parents also. Up to one stage she will help. After that he will grow and he will take care of this total. So this is a systematic thing. Similarly, in our double cage rotor also there is a two windings. One winding, so this is the gall having the some high resistance initially, then so here is a R is equal to inductance value is a very low, here is the inductance value is the resistance mainly dominating, and XL is the less. Inductive value is the less, resistance value is more because she is a gall. And another winding, so resistance and inductive value. So boy, this is a gall, okay, this is a gall, she has high resistance value, low inductance property. So whereas this boy, younger one, has a low resistance value and XL is the very high. Okay, so both are connected in parallel, and so whatever the they will bring to is their house. For example, so what will happen? So the girl and boy, if parents takes suppose some 5 apples, she will or 5 apples are chocolates, 5 number chocolates. Then what will say? So she is the elder, she is the younger. So automatically she will take the 4 apples. Only 1 apple will gives to the this boy because he is the younger. Or 4 chocolates she will take. Only 1 chocolate will give to his brother because he is the younger. She is the elder. Once the boy also growing, then he will expect the 50 to 50%. So during this period, what will happen? So the whatever the required, that is the enough. Okay, initially whatever the current comes here, so due to the here, what will happen? This current flows here, this current flows here. Here resistance is more, but XL is equal here. What will happen? Resistance and XL, resistant XL. Inbuilt resistance is more. Here XL is more, R is bit. But what will happen? In our induction motor, the rotor at standstill condition, the whatever the input supply is given here, the frequency and the frequency also same. If suppose you are given the 50 Hz, okay, then this is also 50 Hz at standstill condition. Rotor speed is equal 0. That means it acts as a short circuited secondary of the transformer. Okay, so what is happen if the frequency is whatever the frequency is applied in the stator side, same frequency in that one. If frequency is more, what will happen? So here XL, here XL. Then so the XL of this is omega L, that is equal to 2 phi f L. So here also what will happen? The XL value is equal to 2 phi f L. So here this XL value is a very low, resistance is more. Then what will happen? Due to the 50 Hz frequency, we are going to the some ohmic value, some amount of the ohmic value. Okay, XL1 we are going to some ohmic value. Now here, so this itself, the XL value is a very high. So 2 phi f is a 50 Hz, same L. So here ohmic value is a very large, as ohmic value is a more as compared to the here. So that means XL2. So here the XL2 is a very greater than the XL1. So due to the same frequency. Okay. So at the same time, the R1 is a greater than the R2. Here resistance is less, inductive value is a more. So in this, due to this one, so what will happen? Here ohmic value total, that means the secondary, this is a coil, here the impedance of Z2 value is very high as compared to the this impedance or Z1 value is less. So that means here Z2 ohmic value is very high as compared to the Z1. Hence we know that the current always flows in less impedance value, less ohmic value. Hence whatever the current will try to flow only in Z1. That means whatever the coming, this is resistance, inductance value, and so this is Z2, this is Z1. So whatever the current comes, so always try to flows low ohmic value. So the current, whatever the current will flows here, whatever the current percentage comes, so more current flows this winding, less current flows this winding. Okay, so nearly, so what will happen? Nearly 80% of current is flows through the low ohmic value, and only 20% current will flows through this value. Okay, so due to this one, what will happen? So here the total rotor resistance value increases here. Once the resistance value increases, automatically the torque, starting torque increases. So here resistance circuit come in picture at starting. Once the frequency of stator frequency is equal to rotor frequency, at that condition, whatever the ohmic value of winding, one winding becomes the more, one winding becomes the less. Okay, this is the one thing. If the rotor is rotated some speed, for example, slip speed, it is rotated. Then once what will happen? The rotor frequency value becomes to the slip times of stator frequency. The slip value is equal to only 1 to 2% under running condition. Instead of 50 Hz, we are going to the 1 or 2%. What is the 2% means? 2 5s are, that is the nearly 10. So nearly we are going to get the, that is equal nearly, so 1 or 2 Hz only. For example, 2 Hz. 2 Hz into, that is equal 2 5 L. So automatically what will happen? The frequency reduced, this resistance value, whatever the second Gauss value, so decreases. That means in this case, once under running condition, Z2 value decreased due to the frequency decreases. Okay, then what will happen? In this case, second case, whatever the Z1 value is greater than the Z2. Hence, whatever the current comes here, so instead of going this direction, so total current will flows the here only under running condition. Then no need of this one, because already inherently, obviously, it has a high resistance. So this ohmic value changes based on the frequency. Initially the frequency of the rotor is more, hence the circuit 1 Z1 becomes the less ohmic value, and Z2 value is a high ohmic value due to the high frequency. Once the motor started running under normal condition, the frequency is reduced from the 50 Hz to the 2 Hz. Then the ohmic value of the Z2 becomes very less as compared to the Z1. Then whatever the rotor current I2 comes, that is going to the only Z2 coil. Hence, so we require that thing, that is it runs under normal condition, such a that we are going to get it initially a high starting torque, under normal condition, normal act as a squirrel cage induction motor, such a way that we can get both properties, high starting torque and normal constant speed is possible with the help of the one girl, one boy, instead of only single boy. Okay, so this is the basic concept of double cage rotor. Okay, so dear students, so don't worry, so we will see this everything with the help of our PowerPoint. Okay, so what we have seen, just let us conclude it. What is the necessity of this one? What is the necessity? We have seen, so here the starting current is small in squirrel cage induction motor due to low resistance in the rotor circuit. Here a method is obtained, the comparatively high rotor resistance at starting and the low rotor resistance when running in cage motors. So what it consists? So it consists of two separate cages. The inner cage, that is the two windings. So here is a this is the rotor, and the rotor has two slots. This is the one slot and another is the another slot, such as that we provided. So here one winding, here is the another winding. So here this is a Z1, here placed the top one, and Z2 is placed in the Z2. So this is the girl position, this is the boy position. Okay, so Z1 consists of what will happen? High resistance, less inductance, whereas the Z2 consists of high reactance and less resistance. So inner cage is deeply, so you can see this Z2, so deeply embedded in the rotor and has a bars of a large cross sectional resistance. If the cross section is increased, the coil, what will happen? Resistance will decreases. As it is a deeper in the rotor iron core, it has a also high reactance value, such as that we provided. Okay, so what will happen? So here the second Z2 coil, that whatever the boy, so having the a thicker conductors, cross section of the conductor is more, hence cross section is increased more, then what will happen? Resistance value decreases. At the same time, we place the deeper in the core magnetic material, then what will happen? XL value increases in deeper winding. And coming to the outer, that is the top one. The outer cage is near to the surface and has a bars of a small cross sectional area. If cross section is less, automatically resistance value increases, such as that I required that one. So at the same time, the inductance value used less. That's why, so I am going to use here the outer surface, whatever the girl is made up of the brass, alloy material, brass, whereas my varasudu, that is a boy, is made up of the pure copper conductors. This is a alloy, because she will always goes to his mother-in-law place only at one time, but my son is always with me. So that's why I am making the copper, pure copper conductor, whereas my daughter is made of the brass, okay, alloy material. Hence, due to the brass, resistance is more, inductance is less. Due to the copper wire, it is inductance is more and resistance is less. Okay, so that is the basic constructions. Now, what is the working? What we have seen working? So at starting, so we know that say FR is starting here. FR is equal to whatever the rotor frequency is equal to stator frequency, and whatever the rotor induced ER is equal E2. At that condition, the current, the secondary current is equal very high, so that the XL of the inner cage is more due to the frequency is more, then that is a 2,5 FL. So Z2 value very high, hence the impedance is more, hence very little current flows in the inner winding. Okay, so that is the boys, draw the very less number of apples. Most of the current, I2 current will flows through the outer cage, and high starting torque is obtained as per the formula. T is directly proportional to the resistance. Initially, when his brother is little, then she will what will she? She will dominate, she will take the more apples. So that means most of the current is flowing through the outer cage only. Okay, so once it produces a starting torque, pick up the rotor, then it will runs. Okay, once it going under normal condition, at that condition the frequency, rotor frequency becomes to the 1 or 2 hertz only. So due to the less frequency, the inductance value of Z2 value also decreases, ohmic value decreases. Under normal conditions, the impedance decreases, the most of the rotor current then flows through the low resistance path. Which is the low resistance path? Now comparing to the Z1, Z2 is the low resistance path, because inductance value decreases and automatically the resistance also less in that. So most of the current is diverted from the circuit 1 to circuit 2. Hence the I square R losses also decreases, and so overall we are going to get the high efficiency of the motor. Okay, so these are the some things we have seen in this before going to our actual class. Okay, so these are basic things, dear students. So based on this one we will see in details. Okay, you can see this is a practical double cage rotor induction motor. So rotor is made up of these two arrangements. This is my daughter. Okay, this is my daughter, is my son. Okay, initially she will help in all aspects till her marriage. Then he will take care of after her sister marriage. Okay, so this is a big size double cage rotor. Okay, now we will see. Now let us see, dear students. So what is the necessity of double cage rotor? What is the purpose? Let us see. Here the main disadvantage of squirrel cage induction motor is its four starting torque of its low rotor resistance. Initially, single boy is unable to continuously help to his parents. Okay, so there is no insert possibility in the external resistance, as in the winding is permanently short circuited at both ends. You can see here, so the figure itself you can see. So this is the, you can see how the bars is inserted. Okay, so this is the slip ring induction motor, slipping rotor. This is the squirrel cage rotor. Squirrel cage, so what will happen? So both bars are inserted, brassed at both sides. You can see this is a brassing, this is a brassing. But whereas in this case, so you can see here, so whatever this one is taken out from the slip rings, we can add that there is a provision is provided here. Okay, so that is the thing. If high resistance rotor bars are used in our squirrel cage induction rotor, the starting torque will be more, no problem, but the efficiency is poor because of the motor rotor copper losses continuously in the motor. If resistance presents in the electrical circuit, it will always consume the energy from the supply. But I require the starting torque at the starting itself only, no need of this under normal condition. Hence, I cannot add the resistance. No external resistance can be added at the time of starting, like own rotor, you can see, because its cage is permanently short circuited at both ends. The starting torque of squirrel cage motor are improved by using a double cage rotor, today hero. Okay, so a method of obtaining comparatively high rotor resistance at starting to give good starting torque initially, and once it pick up the low rotor resistance when running in cage motors, that is a very good efficiency will take place. Initially take one person, after that we will take the another person. You can see this figure. So dear students, is you can see the by x after, you can see this one, this is our daughter. She has the upper cage inserted in the upper cage. Top priority we are given initially because she is the elder one. I given the top priority. So then she has a high resistance power, low inductive power. And in second cage, lower cage, I placed younger my boy. So he has the low resistive power, low resistance and high inductance. He is my Varus 2. Then at the same time, so due to the inner side, I kept inner side, the inductance value increases. So you can see the figure also. This is a double cage. So this is a single cage this is the double cage rotors. Okay, so you can see how the single cage, so if you are going to enter this inside, how the cage is owned in a simple squirrel cage rotor, then I can easily understand what is the basic difference between these two. Okay, let us see. So at a glance you can see that also. So this is a squirrel cage induction motor rotor. It has a stompings laminated, the forming iron core made of the silicon steel to reduce the hysteresis losses, and the laminations are made to reduce the eddy current losses. Already we have seen. The coppers or aluminum bars are inserted in the skewed slots. Okay, so welded at both ends. Okay, so this is how you can see the both the laminations and finished squirrel cage rotor. Okay, so now I want to see that in case of this comparison with our rotor double cage rotor. So here only single cage inserted, only one winding is inserted. Simply I can insert the only one cage. I insert this one. There is no provision. Single slots, only it has the single slots. I insert the copper bars. Now in double cage I am going to use two cages. You can see that also. This is a very good example of double cage induction rotor. You can see that is also. What has happened here? This is a stator. So that means here this is a stator, this is a rotor. In between there is an air gap between the stator to rotor. The rotor has two cages. So bar in upper cage and bar in lower cage. Okay, so the upper cage is my daughter and lower cage is my son. You can see now itself. It is the same laminated to reduce the eddy current losses. Same I can use the good ferromagnetic material, silicon material to reduce the hysteresis losses. Overall, the iron losses is reduced. Now you can see the top one outermost slot, outer cage winding slots. In that one, so outer cage winding has high resistance. You can see here high resistance, low inductance value. So coming to the second inside depth slots, inner slot. So inner cage winding slot, this one, it consists of inner cage winding has a low resistance value or should be the less, and inductance value is very high. We can compare this two. Okay, so whereas in previous cases what will happen? Rotor has only one slot. There is no two business. Here we have the two slots. So here is a one winding, here is the another winding. Two windings are we are used. Here I can use a brass material. Here I can use a pure copper material. So brass has a high resistance and copper has a less resistance. Okay. Now let us see the what are the salient points. Now the efforts have proved that high starting torque in squirrel cage motor can be achieved by using double cage. Okay, so two independent cage windings are inserted in the rotor. The double cage rotor consists of two separate cages on the rotor as shown in the figure. In a double cage rotor, there are two cages on the rotor as shown in the figure. The figure shows two rotor punchings for double cage rotors. Just now we have seen two punchings, the first one and second one, inner one, outer one. Sorry. The outer cage consists of high resistance alloy such as brass. The inner cage has low resistance such as copper bars. So you want to see the enlarge the slots. If you want to see the enlarge the slots, what is the outer cage, what is the inner cage you want to see. So let us see that enlarged portion. You can see here. What is that one? Here, so A, B, 2 cages are provided. Here I can provide my son. Here I can provide my daughter. Okay, A and B. So you can see this rotor with deep bars, and here you can see that the stator which has my daughter is upper, my son is here deeper. So then the deeper bars having the inductance and upper bars having the resistance. You connected, you can see this how these windings in our electrical circuits. Okay, and same thing I can see in another way. Okay, so upper cage what is consist? The high resistance, low inductive values, and lower cage whereas it is a low resistance value due to the copper and high inductance values. Okay, now what is happened here? So from figure shows the two punchings for the double cage motors A and B, 2 slots. The inner cage made up of bar A here is deeply embedded in the rotor core, and it has a bars of a large cross section. That means large cross section means so less resistance value. Thick conductors is provided in slot A. As it is deeper in the rotor iron core, it has also high inductance value. Okay, due to the large cross section area, resistance value decreases, and due to the deeper in the core material, then it becomes a large reactance value. Okay. Now the outer cage, you can see the outer cage made up of the brass B is near the surface, not copper purely. It is a alloy of the material, that is a brass is provided due to the high resistance is required. Has bars of a small cross section. If the cross section of the conductor is less, automatically resistance value increases. Its reactance is low and resistance value is very high. So what we required, this is the things, physical appearance. So these are the construction point of view, how the inner cage, outer cage is placed, how the winding is wound in this one. So these are the physical one. As an electrical student, I want to know that circuit diagram. Okay, let us see that is circuit diagram. This is a one circuit diagram where, so this is a equivalent circuit diagram. So what we have seen, this is a primary side. Okay, this is a Z0. So we can see the R01. So you can see Z01. We can see the Z01. This is the Z02. So this is a magnetic components, two currents, Rx and X0. Okay, this is the R stator side. This is the rotor side. In rotor side, instead of single, I can use a X1 and R1, X2, R2. Okay, so what does that means? Here, this winding is nothing but one winding, the upper cage. This is known as the lower cage. So here, whatever the I2 current comes here, so will flows here and here. Share initially. Initially, she will take more, and it will take the less. Under running condition, it will take the more current here, less current here. Okay, so that is the two sharing of the whatever the apples taken by bring by his parents. Okay, so let us what is happened here? At starting, the frequency of the rotor induced EMF or current is high. Okay, so that I2 current initially what will happen? The I2 current is more, because E2 is equal to induced more. Okay. So, the reactance of the inner cage is equal to this value. So, XL is equal to very high, its impedance are both high values. Hence, very little current flows across this current. Most of the rotor current, whatever the I2 current, will flows through the high resistance outer cage and a high start and torque is obtained. So, here the total I2 current will flows here, and with resistance value increases. If resistance value increases, automatically the torque will increase. The torque is a starting torque initially. Okay. So, after that, at the speed increases, the rotor frequency, the Fr becomes to the slip times of frequency, that may becomes to the, instead of 50 Hz, we are going to the 1 or 2 Hz only. Under normal running conditions, the reactance and hence the most of the current flows through the inner low resistance cage. Now, in this case, this value decreases, this value resistance is contained. So, whatever the current I2 current comes here, most of the current flowing through this one only. Okay. So, that means under normal running conditions, the reactance value of inner side cage decreases, the most of the current ohmic value decreases, most of the current flows through the inner resistance cage only. Hence, it develops a greater part of the motor torque under running conditions. Okay. These are the some relations. This is all we discussed. Now, under normal running condition, the frequency of the rotor EMF is so small that reactance of the both cages can be neglected. The current is carried by the two cages in parallel, giving the low combined resistance. So, both are connected in parallel circuits. So, resultant ohmic value is less than comparing to the any one of that value. Okay. So, then thus rotor copper loss will not be very high, I square loss is very less. Therefore, will not adversely affect the motor efficiency. Motor is the losses is less, then automatically efficiency may not be less value. Therefore, will not adversely affect the motor efficiency. Therefore, at the same time, so we are going to get the high efficiency under running conditions. So, these are the working principles. Okay. What is the working principle? Under start initially, whatever the outer cage ohmic value is less as compared to the inner cage. Then whatever the I2 current comes, the most of the current is flowing through the outer cage only. Then due to this one, the resistance of rotor is more initially. So, due to the resistance is more, starting torque is more. So, what we required, we obtained it. Once the rotor picks up its speed, it is running under normal speed, then frequency reduces, the ohmic value of the deeper winding is less as compared to the outer winding. Then whatever the rotor current is diverted from the outer winding to the inner winding, then it will continuously develop its normal torque. It will helps to rotate the rotor. These are the basic things. Now, let us see the what is the relation between our speed versus torque or slip versus torque. So, because we are the electrical students, we should know what is the relation between the torque and slip. Okay. So, only inner cages, only outer cages, combined these cages, what is the effect of the torque relations, torque slip characteristics we should require to know. Okay. Let us draw the diagram also. So, how we are going to write? You can see here, this is the one example. So, what has happened if initially the outer cage, so this is the outer cage. So, because resistance is high, starting torque is high, you can see So here S is equal 0. At starting, this is the starting, N is equal, here we are going to the 0. So this is the starting torque. From starting torque, it is this much of the starting torque is increased due to the resistance. Okay. Then coming to the second one, inner cage under normal condition. So the starting torque is this much. Okay, the starting torque this much. Now this starting torque. Now combination of this and this becomes to the this value. Total overall the torque, initially starting torque of double cage motor is this much. So it is going increasing up to it produce a maximum torque at this speed. Okay, if the speed further increases, then automatically its torque will decrease. So this is a very familiar the torque slip characteristics, dear students. Okay. So what it says, the torque slip characteristics of the double cage motor as shown in the figure. And when slip is equal to 1 at standstill condition, the greater portion of the torque is contributed by the outer cage only. So this is only. During the running, the outer cage contributes only small portion of the total torque. During the running condition, whatever the outer is the very less, because inner is the contributor more. Okay. So these are the combination we are going to get in the double cage. Initially the inner cage and under running condition outer cage. Combination we are going to get the a good starting torque of double cage rotor. Okay. So dear students, so these are the some construction, the working principle of double cage rotors. Okay. So let us see the what are the advantages of double cage rotor compared to the single squirrel cage rotor. Okay. Advantages. First one is the high starting torque and good efficiency during the running conditions may be obtained, and at the same time useful for frequent starting under heavy load conditions. This can be used. For example, in case of the hoists, lifts in shopping malls, you can see the lifts. So we can start and stop immediately. So at that condition we can prefer the double cage induction motors. Here no need of maintaining the slip rings and brushes when compared to the own rotors. Comparatively low copper loss under normal running conditions. And finally, so we are going to get it the possible of starting the motor direct online because of comparatively low starting current. So we can use the direct DOL starter is enough to start the double cage rotors. So these are the benefits. What is the benefits? One is the high starting torque getting, and it is useful, very useful for the frequent starting under heavy load conditions, and no maintenance for the slip rings, and low copper losses maybe takes place, and possibility of starting motor with help of the simple DOL starter can be used to protect the under short circuit condition, under overload conditions, and no load conditions can be used. So DOL starter cannot be control the initial starting current or voltage. Simply it can protect the our motor from overload and under voltage conditions, and on a purpose we can use the simple DOL starter can be helpful in case of the double cage rotor. Okay. So these are the some benefits of double cage rotors. Okay. Let us finalize so comparison between the these single cage rotors and double cage rotors. Okay. So what are the difference, dear students? Now this is, you can see, okay, this is my family and this is my brother family. He has a daughter, he has a son, but I have only one son only. Then what is the main difference between two? Only one son, the girl and son. Okay, so let us see what is happening here. In this case, the starting current is high, hence not suitable for the direct online starter. Here it will draw the starting current is more initially, so we cannot use a DOL starter. Here I can use a DOL starter, and at the same time T starting also very less, but in this case I am going to get the more starting torque initially. Here what will happen is only one resistance present, effective rotor resistance is low, hence at starting rotor heating is not severe. So here resistance value is less, that is why here whatever the heat is developed is less as comparing to the this one. Here I can what will garden this goal and this wire. So total cost for maintaining is more here. Okay, so effective rotor resistance is low here, hence at start rotor heating is not severe in this case. Here rotor resistance heating is more because outer cage having the high resistance value. That is the one disadvantage. Automatically single person will take the all apples, here they will take the combination of these two. And as the rotor resistance is low, rotor copper losses are less and efficiency is more in this case, because resistance value less, copper losses is less, efficiency will increase. But in this case what will happen? So here initially resistance is more, this losses is more, hence overall efficiency is less as compared to this person. Okay, next, so they will consume the double. The breakdown torque is maximum in this case. Whatever the breakdown torque, we are drawing this torque is a maximum in this case. In this case what will happen? So the girl is producing the one torque and boy is producing this. So both are producing at different speed, hence so we are comparing this one, the effective torque or breakdown torque or maximum torque is more in this case is a less. That is the difference. And leakage reactance is less, XL value, leakage reactance value is less, here leakage reactance is more due to the deeper in this case. At the same time the power factor PF also here some more, here power factor is less. Due to the inductance increases more, automatically power factor will decrease less. So in this case power factor is more. The torque slip characteristics are fixed and constant in this case, but it is with the proper choice of resistance and reactance of the inner and outer cages, the wide range of torque slip characteristics can be obtained as per our requirement. And finally, for the same rating the cost is less here, here cost is more because here the sun and gall is required. These are the some differences between two cage rotors. What are that one? Here some benefits. Here the T, first is the T starting is bad, very good, and starting current is I starting current, I2 is bad, is a good. And coming to that next maintenance part, whatever we require, this is the main important, has the electrical characteristics, we require is more, is a benefit. After that, so maintenance, coming to the maintenance. What will happen? The resistance values are less and ohmic losses are less, copper losses are less, and efficiency is good, but here is the opposite. At the same time, T full load breakdown torque is good here, but its breakdown torque is less here. Okay, and at the same time reactance value is XL value is less here, and PF is more here, but in this case reverse. And torque slip characteristics is a fixed here, torque slip characteristics can change as per our requirement. And finally the cost is less here, the cost is more here. These are the few differences between double cage and single cage induction motors. So dear students, these are the some idea regarding to the our double cage rotor. Let us summarize what we have seen in this class. Okay, you want to see these are the things. Now summarize it. What we have discussed in this class. So one, what is the necessity of double cage rotor motor, its construction features and its a working principle, and at the same time we have seen the torque slip characteristics of this our motor, and finally we have seen the advantages of double cage rotor, and at the same time we compared this double cage rotor with single cage rotors. Okay, so these are the small topic, dear students. Please go through textbooks. Thank you for listening my class.